let me introduce you to the next session. We'll be talking about the production quality, 3D, Gaussian splatting, and mesh. We're going to take a look at what's next. Ladies and gentlemen, let me welcome to the stage the Manager of Product and Business Development, Sony Xyn, Kenny Nakamura. Let's give it up for Kenny.
Hey, nice.
Welcome.
Thank you. Can you hear me? It's OK? All right. Hello, everybody. Good afternoon. So I'm from Sony. And under the Sony, we announced a new sub-brand called Xyn, pronounced Xyn. Xyn is integrated software and hardware solutions to support the creation of the spatial content, which we announced at CES 2 years ago. And but I'm again Kenny Nakamura. I'm under the Sony Electronics and Manager of Product and Business Development. And after this session, please come to the booth, and I would like to connect with you all. So today, I would like to talk about these 5 things. And so I have a lot to cover today, so I'm going to skip some of the slides in the video. But I want to show you a couple of videos first to let you understand what we're working on. Before that, as a software Xyn lineup, we have a software and hardware lineups. Today, we're going to focus on spatial capture solutions and the 3 brothers. But we have motion capture solutions and device, and also the spatial 3D display, which is a glasses 3D display you can see at our booth. Today, so we're going to focus on spatial capture solutions. So these solutions use the mirrorless cameras and also Sony Alpha, of course, and Sony's proprietary algorithm to create a high for quality photorealistic 3D assets, not just the splats or traditional mesh as well. So, of course, the use case, we are seeing in a game, we have PlayStations, we have a bunch of productions, we have 20 pictures, we're in the digital exhibitions industry. But as a day one of the release, we focus on a bunch of productions. So first of all, I want you to take a look at the video.
Xyn.
So we try to digitalize this Japanese beautiful castle, and I use it for a bunch of production backdrops. This is called Himeji Castle in the middle of Japan. In order to digitalize this, you don't need any drone, just only cameras and cameras. So they're fun. So we developed the Navi app called the Navi app to help you capture the scenes properly without any background of photogrammetry or even cameras. The AR marker shows you on the screens and it lets you takes you to the positions that you need to capture. Once you capture this, and you can manage the photos and beautifully, and uploads to the web applications. So please remember this real Japanese castles. So using just a single Sony cameras and a lens and the cameras, and it lets you scan 110 images for 180 degree, and upload the images to our web-based applications, and the select algorithm, hit the creative button, that's it. You don't necessarily to tweak any parameters. And then this is the 3D Gaussians. Look like a little bit, I can show you the more beautiful images out there, but this is pretty high photorealistic. And you can use for the bunch of productions within a day. As you can see, this is our Japanese castles, these 3D Gaussians. Let's move on to the next video. And then this is another use case. We actually work with the Sony Music and create a music video using our Gaussian splat. So, sorry in Japanese, but I hope you guys understand what we're working on. So we went to Hiroshima in Japan, and they captured 11 locations in the same day. And then just capturing these 100 images of these scenes just takes 10 minutes. And then reconstructed all scenes within almost a day. So there is studios and some locations, and it's high school, and a lot of locations in Japan. And the Japanese train for course. And then the AR marker shows up on the screen, and all you need to do is to follow the guide. And then just about 100 images to create a 3D Gaussians. And this is the Gaussian splats for sure. And then visualize it, and then display it to the LED wall. In order to display the large LED wall, we also have the plugin for Unreal Engine, Disguise, and Pixeltop is already available. And then we actually shoot the music video with the famous Japanese artists and musicians here, like this. Right? Let's move on. So again, we currently really focus on batch production backdrop creations, creating the real from real locations to create a batch production set. And then here's some sneak peek, an example of 100 front-facing creation example. It looked like it's 2D photos, but actually a screenshot of 3D Gaussians that we generated. As you can see, even the far distance of each contents, like this is the top of Shibuya, you can see high fidelity of either far distance as well. So within the batch workflow, in order to create the batch backdrop, there's steps from capture to display. We created the 3 solutions, from capture and then generations and display. For the capture side, it's called Spatial Scan Navi, and then generation spatial scans and the renderer. The Navi app is a smartphone application that supports the shooting spatial contents with the mirrorless cameras, the real-time shooting assistance with the AR navigations, and the real-time visual shooting status, and also the manage the images. When you upload, it's pretty easy, and what you can understand where the images start, a file, and end. So this is a kind of UI. So within the iPhone Navi, so AR marker shows up, and then once you capture that, these hexagons will disappear, and then visualize where you capture. And also not just the scenes, but also there is the for the object capture as well. So visualize, and you can understand where that for us, and you don't miss it with the visual help. And the spatial scan, this is where the magic happens. The cloud-based application transforms the real world into the 3D CGs. So the production quality assets creations, and where you can generate the splats for splats and mesh objects, and for the front-facing scene generations. For this, let's take a look at from object scan. Of course, Spider-Man, and from Sony. We generated these assets, and also the mesh as well. So our mesh is really good at reproducing these scenes or details, and also even a reflective surface or scene parts like this. Our mesh is totally clean, without any modifications or cleanup work. It's ready to use. So we, as a use case study, we worked with the Honda, and as a proof of concept project. So their challenge is, they wanted to digitalize the legendary motorcycles, but they don't have 3D data because it's too old. So they don't have any cathode data, so there's no way. So there's issues from they have to create it from scratch, but using traditional 2D photo, there's a lot of difficulties and takes a lot of time. So we scanned this real bike and turned them into our mesh, and then they recreated from scratch as well. So as a user reference, but from the scan, as you take a look at it, you can see the details of the mesh of the vehicle. Actually, it's usable for the project. For the front-facing scene, what we know that this is an example of high resolution reproductions of distant scenes. When you look at the left side and the far distance, using the same input and same images, but we created really far distance, recreated the far distance really well, or reducing the floating noises like this. And then this is really simple. We try to democratize the step to create the Gaussians. So all you need to do is just to create a project, upload images, and the select algorithm depending on the use case, and then hit the create button. That's it. Just then wait 1 hour up to 3 hours, depending on the quality you want, and then everything happens here. Like you can generate the splats in a mesh. Just a word for the Render plugin side. This is for more batch productions. This can be used. There's a couple features. For example, HDR support, in natural lighting, and also the color collections, and in creating bokeh. This is very basic functions for the batch productions. like this, red lighting, and then, oh, sorry, coming back, and come back, and the color collection as well. And at our booth, actually, we also showcasing our prototype of this Spatial Scan Editor. So this corrects the 3D Gaussian points, orientations, and also we have, and you can remove the splats pretty easily, just select it. And also the compositing tools. You can add the multiple 3D Gaussian splats and then also change the color of each splats to blend them in. And also we have our Spatial Visual Videographers. So adding the splats and then create some video movements easily. So AI can create some camera movements, and also you can manually change the camera movements. So if you wanted to use, create some video using the splats, this solution can let you create really easily video using the splats. Again, so the plugin supports the Unreal Engine, disguise the pixel top. And also we have Sony Virtual Production teams, and it works with them. And so we are only the company where we built the hardware, like LED wall, and also cinema cameras, Venice, and also the camera, markerless tracking device called Oscillus. And also we have the software to create the batch backdrops. And then more to come. Okay, thank you for listening. And I'd like to discuss with you guys at our booth. And please scan this QR code that takes you to our webpage to get more details. And there's some of the other comparisons, and then those are the of our splats, and the more informations. Thank you.
Thank you. Kenny, thank you so much. Come, join me at the center of the stage. We've got a couple of questions, and you were, ahead of the time, so we've got plenty of time to actually tackle those.
Yep.
Let's bring them up on screen, please. So let's start with the first one. Do you take the photos from a single standpoint, or whilst moving around during the capturing process? What limitations does it have when moving laterally through the scene?
Yeah, so when we do capture, actually we do from the single standpoint mainly. And then, so the arrow marker shows that the partitions of the cameras starting like this, and then capturing 55 images, one layer.
Yeah.
And then 2 layers in total, so which ended up in capturing 110 images. So you're gonna move like this a little bit, and then capturing towards, so that you can get the depths. So that when you do the budget productions, you can pan the cameras until that, the layer you captured, and also zoom into it.
Got it. Let's move on to the next one. Does it support any mobile device? If yes, which ones?
So currently, we support only Sony, iPhones because with the LiDAR. And if you wanted to use the Navi app, it works with only certain latest Sony Alpha cameras. But eventually, we will try to support more cameras. And but at the point, in terms of the mobile device, it has to have a LiDAR. So currently, an iPhone is the only one option. But just mention that for the web application side, the where the magic happens can support any images. So you can use any cameras.
Got it. Thank you. What is the technical approach behind creating the mesh?
Yeah, so we have one proprietary algorithms to create a really clean mesh. So we capture even the car, and the car has a lot of shiny surface, and also even the glasses. But using our own proprietary technology, which I cannot disclose everything, but our meshes, and also even the splats are using our own proprietary technology to make it higher fidelity. And so then also using the meshes have defined there's a secret sauce in it. So.
Perfect. Well, you showed us a project of scanning the Himeji Castle. What was the most complicated project you worked on?
Yeah, so there's spheres, from the rooftop. At our booth, I can show you the real sample we captured from a rooftop at Sevilla. And then, as you can see, that later, the slide that I showed you, the Sevilla has a lot of details and a lot of different shapes. So that was kind of a little difficult because it only limited a certain area. But thanks to our technology and Navi apps to help me capture those complicated scenes, I've never actually been scanning so much before I got involved in this project. So that's helped me a lot.
Cool. How long does it take to combine all the individual images into a model?
So the capturing side just takes 10 minutes. Once you get used to it, less than 10 minutes. And then Appro takes like a few minutes, depending on network connectivity. But the reconstruction side, depending on the algorithm you choose, but if you are okay with the certain quality, less than an hour. But if you want to achieve the higher qualities, maybe 3 to up to 6 hours with the HDR contents.
Got it. Let's tackle 1 or 2 more, and then we're going to wrap it up. We still are good with time. So what about generation of 3D models for critical infrastructure inspection with high level of details, a sub-millimeter of GSD to detect the cracks and defects?
Yeah, so we are seeing in this use case as well in the futures order map, but adding the more accuracy and with the lighter tech, and because our algorithm is fusion ready. So meaning that not just the RGB images, but also we can combine a lighter tech so that we can create that high accuracy in the features. But currently, as I showed as a day one, we really focus on a bunch of productions. That's totally different use case, I believe.
Awesome. And somebody wishes you good luck. That's so nice of you. Thank you.
Thanks so much.
Let's give it up for Kenny.
Thank you.
Ladies and gentlemen, Kenny Nakamura.